Hello everyone. Am I audible to all of you? Anyone? We will wait for a few minutes more and then we will start. Let's wait for some time for others to join and we will start today's discussion. So let's start today's session. Hello everyone. A very good evening to all. I welcome you again to the interaction session on experimental physics 1, which is being flowed this semester by NPTEL with course code NOC23-ph37. So today is the last interaction session. So I will try to cover all the remaining topics and the questions based on it. So myself, Vivekananda Naik, I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So let's start with our session. So in last class, we had solved 3 problems. So now let's start with the fourth one today. So the question says, suppose that the resistance R of the loop in the actually there is a question I will mention after some time. So in previous question number 3, there was a situation given. So we will relate with that question. So it is given. Suppose in the previous question the resistance of the loop is 10 ohm. What will be the induced current in the loop if the loop is kept stationary and the magnetic field is steadily reduced to 0 in a time 40 milliseconds. So in the previous problem, what we had discussed yesterday, there was a rectangular loop. It had some number of turns. Now, and it was placed in a magnetic field with some angle. So there are two situations. One, this was making an angle 30 degree with respect to this lines of force, and it was rotated such that it makes an angle 90 degree with the lines of force. So we had calculated in the initial case, the flux associated with it was 0.2 Weber, and in the final case, when the rectangular coil is perpendicular, the face of the coil is perpendicular to the magnetic field, then the flux was 0.4 Weber. So in that case, magnetic field was same, but due to the rotation of the coil, the flux associated with the magnetic field was varying, because if you see the magnetic flux, what is the formula for magnetic flux phi? It is B dot A or B A cos theta. So this cos theta is a factor which depends upon the angle it makes with the lines of force direction. So in a particular case, if you see, suppose this is a coil, a rectangular coil, and it is present in XY plane, then its area vector, because here it is the dot product between two vectors, B vector and A vector, and we know area vector is always perpendicular to the plane. So the area vector will be along Z direction, is not it? So suppose this is in a plane, so the area vector will be along a direction which is perpendicular to the surface area of the circular coil. So in this case, suppose this was theta, but actually the angle will be 90 minus theta. 90 minus 30 will be 60 degrees. So initially it will be 60 degree, and when the, now you can clearly suppose this is the direction of lines of force and the coil is present here. So this is the face of the coil. It is bit difficult to draw it in 2D. So this is the face of the coil. Suppose this, the situation when you look from above, situation is like that. So the face of this is the coil and this is the magnetic field. So the area is in this direction. So the area vector will be along the direction of magnetic field. So when it is 90 degree, the theta will be 0 degree, because the area vector is always perpendicular to the surface area. So in that case, we had calculated that there will be an induced EMF of 0.4 volt, because the initial magnetic flux associated with it was 0.2 Weber, and the final magnetic flux associated with due to its rotation was 0.4 Weber. So we had calculated in such a way that we'll be able to find the EMF induced in that coil. But here what is it is given? It is given the coil is the magnetic field is steadily reduced to zero in a time 40 millisecond, and the loop is kept stationary. So the in that case, what we are changing, the angle between magnetic field vector and the area vector were changing, and due to which the flux linked with that coil were changing. But here in this question, in today's question, it is given it has some resistance R, which is 10 ohm, and here the magnetic field is changing. The magnetic field was changed from magnetic in the previous problem, the magnetic field value was 0.4 Tesla, and it was changed to 0 in 40 millisecond. So in 40 millisecond, there is a change in magnetic field. So we know the flux is B dot A. So when B equal to 0, flux is 0. So in the previous question, initial flux was 0.2 Weber. So now the final flux is 0. So there is a change of flux. So the change of flux is how much? D phi is 0.2 minus 0 is equal to 0.2, and the time taken to reduce it to 0 is given in the question. It is how much? It is 40 millisecond. This is 40 millisecond. So it is 40 into 10 to the power minus 3 second. So now we know the EMF is equals to minus d phi by dt, is not it? This negative sign comes due to the conservation of energy, which is governed by the Lenz's law here. And the Lenz's law states that the current which will be produced in the circuit, it will create a magnetic field which will oppose the magnetic field which is the source of this current. So the negative sign comes only due to that factor. So if you calculate neglecting the sign, it will be 0.2 because d phi is 0.2 and dt is 40 milliseconds. So it will be how much? It will be 5 volt. So the EMF is 5 volt, which is induced in the coil. Now in question it says, what will be the induced current? The resistance is 10 ohm. What will be the induced current? So we know V equals to IR. So I will be V by R. V is 5 volt. That implies R will be, and R is given 10 ohm. So it will be 0.5 ampere. So the current produced in the coil is 0.5 ampere and it is the answer. Is there any doubt in this question? Anyone? Is there any doubt in this question? Okay, so let's proceed towards the next question, because I will try to cover more number of questions today. So if you have any doubt, please stop me in between and ask me. I will try to explain all the things related to that problem. So now the next question of today's session. The question says, in the circuit shown, the battery has EMF E and internal resistance R. The switch S is closed at time t equal to 0. If the voltage across the capacitor is 90% of the EMF E of the battery after time t prime, then what is the value of t prime? The options are RC log 10 e to the power 0.9 by RC e to the power 0.9 by RC and R plus R C ln 10. So this question is based on RC circuit. So in this case, we know when there is an EMF E in the circuit which has internal resistance R, then the switch S is closed at time t equal to 0. Then the voltage across the capacitor is 90% of the EMF E of the battery after time t. What is the value of t prime? So actually, this is a problem of RC circuit, and in case of RC circuit, this quantity RC, which is called as time constant. This is a characteristic feature of a particular RC circuit, and this time constant gives the amount of time which is taken by that capacitor present here to get charged by some fraction, and this fraction is how much? This fraction is 37%. If you are considering in case of charging, and if you consider in case of discharging, it will be 1 minus 1 by E. So now what happens? The question says the voltage across the capacitor is 90%. So as the current, so since this is positive, so the current will flow in the circuit in this way. So due to this current, the capacitor will be charging up. So it will take some time to charge, which will depend upon this time constant of that capacitor. So in the question it is said that the voltage after a certain time t prime, that is at t equal to 0, there was no charge on the capacitor. But at certain time t is equal to t prime, there was some charge in the capacitor developed which was not equal to 0. And due to this charge, we know C is equal to Q by B. So B will be So B will be Q by C. So due to this charge stored, the voltage will be also the voltage across the capacitor will also rise because the capacitor is charging, and due to the process of charging, the charge is increasing on the capacitor. So the voltage drop across the capacitor will also increase. So what is the voltage drop after the time t prime? The voltage drop is 90% of the EMF, that is 9 by 10 of the EMF E. So this is the voltage after time t prime across the capacitor. So now we need to find out what is that time after which the voltage across the capacitor will be 90% of the maximum value. So if what happens in case of capacitor, when it charges, the relation is given by Q is equals to Q0 1 minus e to the power minus T by RC, where Q0 is the maximum charge that can be stored in the capacitor. So this is the maximum charge. So if you can see, if you put here T equal to RC, then Q will be how much? Q will be Q0 1 minus 1 by E. So 1 by E is 37 or 0.37. So it will be 0.63 Q0. So this time constant RC is defined as the time required to charge the capacitor 63% of its maximum charging capacity. So this is a time constant RC. So this is the basic definition of RC. I had discussed it yesterday. You can refer to that lecture. I have already uploaded it in my channel, YouTube channel, and you have already the link. So this is the case when the capacitor is charging. So since this is the relation of charging, similarly the voltage which is getting developed across the capacitor, similarly V will be V0 1 minus e to the power minus T by RC, because you can see Q, V and Q have direct proportionality. So the voltage will be this much. Now this V0 is the final voltage or the maximum voltage, and here it is written the source in the circuit is connected to a EMF, connected to a source of EMF E. So this V0 is E in this case. So what we will do, we will calculate the time after which, so at time t equal to 0, there was some charge Q which was 0. So at time t equal to t prime, there will be some charge Q prime and there will be some voltage V prime. Now this V prime is the 9 by 10 of E, that is 90% of the E. So if you calculate, then when you solve it, it will be how much? Now if you put this relation, if you put here t equal to t prime, now here as you can see, the EMF has an internal resistance R and there is another resistance capital R which is connected. So the resultant resistance will be R plus capital R. As they are in series, they will be added up. So the time constant here will be converted to R plus R into C. So in this case, this V prime is 9 by 10 of E, which is equals to E, that is V0 into 1 minus e to the power minus T, that is time t prime by RC. RC means R plus R into C. So this is the relation. And from this relation, we can find out the time t. So here, this E gets cancelled out. It is 1 minus e to the power minus T prime by R plus R into C is equals to 9 by 10. So 1 minus 9 by 10 will be e to the power minus T prime by R plus R C. Then this is 1 minus 9 by 10 means 1 by 10. 1 by 10 is e to the power minus T prime by r plus r into c. So if you take natural logarithm on both sides, this exponential will vanish. So it will be ln 1 minus ln 10 equal to minus t prime by r plus r c. Now this is ln 1 is 0. So what will be the actual value? It will be similarly this negative sign will get cancelled out on both sides. So t prime will be r plus r, which is in the denominator on the right hand side, will come to left hand side. It will be r plus r into c into ln 10. So this is the time period after which the voltage across the capacitor will be 90% of the maximum voltage, that is the EMF E, which is connected in the circuit in series. So this is the important question. So I'm explaining it once again. So in this question, it was given that there is a circuit in which an EMF and source with EMF E is connected, having an internal resistance small r, and it is connected to a resistance and capacitance, both are in series. So since it is a series RC circuit, there will be some time constant, and due to the time constant, there will be charging and discharging of the capacitor. Since there is an EMF in the since there is a source or voltage source is in the circuit, so the capacitor will charge. So it will take some time to get charged up, and due to this charge, there will be some voltage drop across the capacitor, and that voltage drop we need to find out after what time will be 90% of the EMF E of the battery. So we put here in case of V we put 90% of E, that is 9 by 10 of E, and in case of this and in case of the relation we put t prime here, and in case of r in place of r we put here r plus r, because the source has some internal resistance, and both the resistance when they are connected in series, the resultant resistance is the sum of the two resistances. So we solved the equation and we found that the time required for which it will the voltage drop across the capacitor will be 90% of the maximum voltage E is r plus r into c into ln 10. So the correct option will be option D. Is it clear to all of you? Yes. Okay, so let's go to next question. Now, this is another example of an RC circuit. Now, the question says a capacitor C is charged to V0 volt and is discharged through the series combination of two resistances R ohm and 2R ohm by closing the switch S. The base of the natural logarithm is E. What is the current in the circuit when 3 RC seconds are elapsed after closing the switch? So now in previous question we discussed the case of charging of capacitor. Now in this question it is the case of discharging of the capacitor. So there is some different relation for discharging of the capacitor. So I will give you a few minutes to try this question and then I will solve it. For your convenience, let me give you the relation which is used here. Here it is given the what is the current in the circuit when 3 seconds are elapsed. So the relation for discharging case is Q is equals to Q0 e to the power minus T by RC. This is the general relation of the, this is a general expression for the charge in the capacitor while it is discharging. Now you can clearly see the charge will exponentially decay because it is the relation has it is direct proportional to the negative factor of the exponential. So the charge developed across the capacitor will decay exponentially. So in the case of charging case, the charge increases in this way, and in case of discharging, suppose this is a charge Q0, it will decrease like this. So this is the time, this is charge. This is charging case, this is discharging case. So please try this question and we will discuss after some time. Yes, anyone tried? So in the question it is given, there are two resistances R and 2R. So the resultant resistance are equivalent resistance is R plus 2R, 2 is equal to 3R. So this relation now changes for the given circuit. Q is equal to Q0 e to the power T by 3RC. Now the question says what is the current in the circuit? So we know current I is equals to dQ by dt. Or here this Q is this Q. So this current in the circuit dQ by dt will be Q0 by 3RC e to the power minus T by 3RC. Here another negative sign will come, but here we need to only find out the value of the current. We don't need to find out the direction, so we can neglect the negative sign. But how the negative sign comes? Actually, what the negative sign implies? So if you see here in the previous question, the current was flowing in this way. This was the current, but when there is no power supply here, the capacitor will drive the circuit in an opposite direction. So that's why the current in both the cases will be same. Whether the capacitor is discharging or the capacitor is charging, the current will be same. But in case of the discharging of the capacitor, since the capacitor is driving the whole circuit, the current will be opposite to the previous case. So here negative sign we had ignored. Now we need to find out what is the current when 3 seconds are elapsed after closing the switch S. So when we, sorry, 1 minute. So sorry for the disturbance. Now, so what we will do? Now the question says what is the current in the circuit when 3 seconds are elapsed? So this T will be 3 RC. So if you put T is equal to 3 RC in the question, T is equal to 3 RC. If you put I will be Q0 divided by 3 RC into e to the power minus 3 RC by 3 RC. It will be Q0 divided by 3 RC into 1 by E. And we know V is what? V is now for a capacitor, the in this relation here we have already discussed. This is the relation for capacitor. V is equal to Q0 by C, Q or Q by C. So if the charge is Q0, then the voltage V0 will be Q0 by C. So if you put this value here, then I will be Q0 by C is V. So it will be V0 by 3R into E. So this is the current in the circuit after the time 3 RC. So in the place of time T, we put here 3 RC. So this is the value of current. This is the value of current V0 divided by 3 RE. Then next question. The question says in the above question, the voltage across the resistance and the current in it immediately after closing the switch are respectively. So the case is similar. Now the question says what is the voltage across resistance R? That is this resistance. What is the voltage across this resistance R when immediately after the closing of the switch S? Resistance R and the current in it. So what is the voltage and the current? So what is the voltage across the resistance R and what is the current just immediately after the closing of the switch S? So we know here we found Q is equal to Q0 e to the power minus T by RC. So if you put T is equal to 0 because here it is given immediately after closing of the switch. So when we put here T is equals to 0, then what will be the value? So at T equal to 0, I will be, so at T equal to 0, this I will be dq by dt, which is, it was given here I is Q0 by 3 RC to the power T by 3 RC. So if you put T is equal to 0, it will be 1. So it will be Q0 by 3 RC only. So the I0 is Q0 by 3 RC into e to the power minus 0. It will be Q0 by 3 RC. Now we know Q0 by C is V, is not it? So when V0 is Q0 by C, then it will be V0 by 3R. So the current immediately after the switch S is closed is V0 by 3R. Now in these two options, the current is same, but what will be the voltage across the resistance? Or what will be the voltage across the resistance R? Now in the circuit, if you see, the circuit was like that. This is a capacitor and there are two resistances. One is here, another is here. This is R and this is 2R. Now when the capacitor is discharging, there is a current I which is flowing in the circuit. Now this capacitor acts as a source. So now this for this capacitor, what is the voltage? This voltage is Q0 by C V0. So the total voltage of the capacitor, which the maximum voltage the capacitor can provide the circuit is V0. So this is the voltage which will drive the circuit. Now this voltage V0 will drop across this R and drop across this 2R, is not it? So if you use the formula for voltage division formula, we know V is equals to IR divided by R equivalent. V is equal to IR. This R is R by R equivalent. So if you put here, the total voltage is V0. So V will be, here it will be V0. So V0 R by 3R, because R equivalent is R plus R 3R. So the voltage drop across the resistance R will be V0 by 3, and the voltage drop across the resistance 2R will be V0 minus V0 by 3, because some resistance X will be here and the remaining V0 minus X will drop across this resistance 2R. So it will be V0 minus V0 by 3, which will be 2 by 3 V0. So it is simple. If this is V0 and the equivalent resistance is 3R, so the voltage will be divided in such way that 2 times will drop across this 2R and 1 time will drop across this R. So total 3R, so V0 by 3 is one part is V0 by 3, so one part will drop here and two part, that is 2 V0 by 3 will drop across the resistance R. So the option is option C, V0 by 3, and the current is V0 by 3R. So this is the correct answer to this question. Now, question number 8. The question says, Lenz's law is a consequences of the laws of conservation. Of what? We have already discussed it many times. The Lenz's law is in accordance to the conservation of energy, because if according to the law of conservation of energy, the total energy of the system remains same, the energy is conserved. So in order to conserve the energy, the if the current is produced in the same direction, then the energy will increase. But in order to conserve the energy, the current is always induced in the opposite direction, and so the Lenz's law of the consequences is the consequences of conservation of energy. Then question 9. Question 9 says, a long wire carrying a steady current is bent into a circular loop of 1 turn. The magnetic field at the center of the loop is B. It is then bent into a circular coil of n turns. The magnetic field at the center of the coil is magnetic field at the center of the coil of n turns will be how much? So a long wire is carrying a steady current and it is bent in a circular loop. Now suppose the length of the coil, the length of the wire is, suppose length is L. Now it was in first case, it was converted into a circular loop. Circular loop means the circumference will be the total length, that is 2 pi r is L. So until the radius of the circular loop, it will be L by 2 pi. It is the first case. Now what happened to the second case? In case of second case, it was converted to a circular loop of n turns. So it will be n loop. So it will be n into 2 pi r. R2 लिख देते हैं, R1. So R2 is, so now R2 will be L by 2 pi n. So these are the two values of R. Now, if you remember, the magnetic field across the magnetic field at the center of the loop is given by B equals to mu 0 I by 2R. That is mu 0 by 4 pi into 2 pi. N is the number of turn, I is the current, divided by R. So in the first case, R is L by 2 pi. This 2 pi gets cancelled out. So it will be mu 0. N is 1 because it is only a single one circular loop. It will be mu 0 by 2 pi. You can say it will be mu 0 by 2. And there will be 2 pi here and L here. R is L by 2 pi, so pi will go to the, this is I, so it is this 2 gets cancelled out. So the value of B will be how much? Mu 0 I pi by L. So this is the value of B. So in the first case, the magnetic field at the center of loop B is given by mu 0 I pi by L. Now, in the second case, if the if the loop is converted into if the wire is converted into loop so that it contains n turns. So similarly, the magnetic field B prime will be mu 0 by 4 pi into 2 pi n I divided by R2I. So if you put here this 2, it will be 2 pi will cancel out. So there is one n here and there is another n here. So it will be mu 0 I n square divided by into here it will be 2 pi, here it will be divided by 2l. So this 2 get cancelled out. Mu 0 I n square pi by l. Here it is mu 0 I pi by l. So this relation will be b n square. So the b prime in this case is b n square. So the magnetic field at the center of the coil of n turn will be n square b. So when you are this is the what we can draw from this question. So if you make a circular coil, the magnetic field, if you make it number of turns, the magnetic field will increase and it will increase as square of the number of turns. So if you are making it 4 turns, so the magnetic field will be 4 square 16 times that of the initial value. Is that clear to all of you? Okay, so let's go to the next question. The question says the magnetic flux linked with a coil is given by the equation phi is equal to 3t square plus 4t minus 9 Weber. The magnitude of induced EMF at t equal 2 seconds is. So it is a very simple question. Can anyone tell me what will be the magnetic flux? What will what will be the EMF induced if the magnetic flux 3t square plus 40 minus 9, which is changed since it is the magnetic flux is a function of the time, so it will change with respect to time. And at time t equal 2 seconds, that will be the EMF induced in the coil. Can anyone solve and tell me? I'm giving you a few minutes. So please try this question and tell me what will be the value of the EMF that will be induced in the coil. Yes, can anyone tell me what will be the value of the induced EMF? It's very simple. The EMF is given by d phi by dt. So it will be d by dt of 3t square plus 4t minus 9. So it will be 6t plus 4. So at t equal to 2, it will be 6 into 2 plus 4. 12 plus 4 will be 16 volt. So the EMF induced in the coil will be 16 volt. So now question number 11. Question says the resistance of an ammeter of range 2 ampere is R. The shunt resistance required to make its range 6 ampere is. So now what is the question? The resistance of an ammeter of range 2 ampere is R. So the shunt resistance required to make its range 6 ampere is. So yes, can anyone tell me what will be the value of the shunt resistance so that the value of the range of the ammeter will be 6 ampere? Yes. So initially the resistance of an ampere in the two A range is R. So what will be the, so now suppose this is an ammeter, this is an ammeter and the range is 2 ampere. So it can conduct 2 ampere of current, or it maximum current of 2 ampere can pass through it, and it has the resistance R. Now we need to connect a shunt so that the shunt resistance will make the circuit in such a way that the total combination will drive, or total combination can take 6 ampere. So shunt resistance means a resistance which will be connected in parallel. So this is the whole circuit. Now this circuit, initially it was, the range was 2 ampere, but when you make the circuit by connecting a shunt, then here it will be 2 ampere. So where, when the range is, we want to make the range 6 ampere. So if 2 ampere is passing through the ammeter, then the remaining 4 ampere will pass through the resistance R. Sorry, this resistance, shunt resistance, suppose the shunt resistance S and resistance R is here. So we need to find out the value of the shunt resistance so that the current will be divided in such a way that 2 ampere will pass through the ammeter and 4 ampere will pass through the shunt resistance. So the total value of the current is 6 ampere. So we know if the two components are connected in parallel, the voltage drop across them remains same. So the voltage drop across this ammeter will be equal to the voltage drop across this shunt. So we know V is equals to IR. So it will be I ammeter into resistance of the ammeter, and it will be equal to I of the shunt and resistance of the shunt S. So now in this case, I ammeter is 2 ampere into its resistance R, and I shunt is 4 ampere and the resistance is S. So if you do the calculation, S will be what? S will be R by 2. So if this R by 2 resistance is connected in this circuit at in parallel to this ammeter, since the ammeter has resistance R and it is R by 2, so twice of the current that is passing through the ammeter will pass through this shunt. So the overall combination will be 2 ampere and twice of 2 ampere is 4 ampere. So 2 ampere plus 4 ampere, total current will be 6 ampere. So if you want to change the range of the ammeter, we need to connect a shunt whose resistance is R by 2. We had already discussed a few similar problems in earlier sessions. So is there any issue? Is there any doubt in this question? Anyone? Okay, so let's proceed to the next question. The question says, a long straight solenoid of cross-section area 10 centimeter square has 10 turns per centimeter. A short 50 turn coaxial coil of cross-section area 2 centimeter square is fixed inside the solenoid at the middle. The mutual inductance of the solenoid and the coil is how much? So I request you to please try this question, and after a few minutes we will discuss. There is a long straight solenoid and the area of cross section is 10 centimeter square and the number of turn is 10 turns per centimeter. A short 50 turn coaxial coil of cross sectional area 2 centimeter square is fixed inside the solenoid at the middle. The mutual inductance of the solenoid and the coil is what? The coil is what? 400 or 40 or 4 pi or pi, and the answers are in microhenry. So when there is, so now there is a solenoid. So there is a long straight solenoid. Now suppose this is a long straight solenoid. It has some number of turns like that. And the area of cross section is 10 centimeter square and the number of turns per centimeter is 10. So there is 10 turns per centimeter. A short 50 turn coaxial coil is fixed inside the solenoid at the middle. So at the middle, there is a small solenoid or coaxial coil. Now this has 50 turns. So here it has total 50 turns and the area of cross section is 2 centimeters square. Now what is the mutual inductance? Now in this case, the mutual inductance is given by mu0, number of turns of the primary coil, number of turns of the secondary coil and area of the secondary coil. Now this number of turns of the primary coil is the number of turns per 1 meter and the secondary coil means the total number of turns in the secondary coil. So if you put the formulas, now we know this mu0 is the magnetic permeability of the medium. Or, this value is 4 pi by 4 pi into 10 to the power minus 7 into, suppose it has 10 turns per centimeter. So it will be having 10 into 100 turns per meter. So it will be 1000 turns per meter. So 1000 turns into ns is number of turns in the secondary coil. Secondary coil is 50 into area cross section of the secondary coil. It is 2 centimeter square. So 2 into, when you convert centimeter into meter square, is 10 to the power minus 4. So if you calculate, all are given in microhenry. The options are given in microhenry. So if you calculate, it is 10 to the power minus 7, 10 to the power minus 4, and 10 to the power 3. So 7, 4 is 11, 3 is 8. So 1 is here. So it will be 4 pi into 10 to the power minus 6 Henry. So 5, 50 into the 100, 3 into this 2 is 3 plus 2 is 5 and 7 plus 4 is 4. 7 plus 4 11, 11 minus 5 is 6. So 4 pi into 10 to the power minus 6 Henry or 4 pi micro Henry. Here this mu means micro, 10 to the power minus 6. So it will be, third option will be 4 pi micro Henry. Then question number 13. Question says the secondary coil in the above question is moved with uniform velocity coaxially over a distance of 2 centimeter in 2 seconds when a current of 2 ampere flows through the solenoid. The EMF induced in the coil during the motion is. So now we know the magnetic field is uniform inside a solenoid. So when the solenoid is moving at whatever be its velocity, at every point the magnetic field is same. So since the magnetic field is same in both cases, so the change in magnetic field will be 0. So due to this change, so since the magnetic field changing is 0, the flux, the rate of change of the flux will again 0. So since the flux is same, so there will be no induced EMF in the coil. So the induced EMF in the coil will be 0. So I will explain it to you again. So now we know the magnetic field is given by mu0 Ni per unit length. So from this value you can clearly see the magnetic field is constant inside the solenoid. So the magnetic field is like this. So the magnetic field is constant in the solenoid. So at every point here the magnetic field is B, here the magnetic field is B, here the magnetic field is B. So now this small solenoid, when it, suppose the solenoid is here and after some time it is here and after some time it is here. So the magnetic field, it is moving in uniform. So there is no change in magnetic field. Since the magnetic field is not changing and it's obvious that when it moves, its area of cross section also remains the same because it is the same coil. So the coil is also same. So since both the area and the magnetic field is same, the flux which is linked with that coil due to its area and it is since it is a magnetic field will be also be same. So there will be no change in the flux. That is del phi will be 0. Since del phi is 0, the EMF induced is 0. So there will be no EMF that will induce in the coil during the motion. So whatever be the velocity, whatever the distance, since the current is same, or since the magnetic field through which it is moving is same, there will be no change in the voltage. So now the next question. The question says, suppose the solenoid carries a current of 4 ampere. If this current is switched off in 100 milliseconds, the EMF induced in the secondary coil will be. So now since here in the previous case, this current was constant because the current was 2 ampere which was flowing through the solenoid. But here this current is changing. Now the current which is changing, it changed from 4 to 0 in 100 milliseconds. 4 ampere to 0 ampere in 100 milliseconds. So since there is change in current, the magnetic field also varies. So due to this change in magnetic field, there will be change in flux. So there will be an induced EMF. So so can anyone tell me what will be the induced EMF in the secondary coil? Because we know the mutual inductance in this case. In the question, we know the mutual inductance. This mutual inductance is 4 pi microhenry. And if you remember, we had already discussed the EMF induced in which we had already discussed the formula in which we had derived the EMF induced in the form of or as a function of the mutual inductance and the rate of change of current. So we will use that formula here only and we will calculate the induced EMF in the coil. So we know the EMF induced in form of mutual inductance and the rate of change of current, because due to change in current there is a change in flux and it is given by the induced EMF is equal to minus m di by dt. So we know m we had calculated it is 4 pi microhenry, 4 pi 10 to the minus 6. The change in current changed from 4 to 0 in time period 100 millisecond, that is 100 into 10 to the power minus 3 second. So this is the value, and if you calculate it, it will be how much? It will be 10 to the power minus 3 into 10 to the power 2 into 10 to the power 1. So 4 into 4, 16 pi into 10 to the power 10 to the power minus 6 into 10. So it will be 160 pi into 10 to the power minus 6 volt. So this will be the EMF that will be induced. Sorry, I calculated in the wrong place. Let me erase it and write in the so we know the EMF is given by minus M di by dt. M is how much? M is 4 pi into 10 to the power minus 6. I is 4 minus 0 divided by 100 into 10 to the power minus 3. So if we calculate it, it will give 116 pi into 10 to the power minus 5. Or if you do, it will be 0.16 pi into 10 to the power minus 3 volt or 0.16 pi millivolt. It will be the correct answer. Then question number 15. Question says a galvanometer having a coil resistance of 50 ohm gives a full scale deflection when a current of 10 milliampere is passed through it. The value of the resistance which can convert this galvanometer into an ammeter giving a full scale deflection for a 2 ampere current is. So it is a similar question to that of the previous question we had discussed to change the range of the ammeter to 2 ampere to 6 ampere. Here the range is to be changed from 10 milliampere to 2 ampere. Yes, so can anyone tell me? So in the previous case it was IR or I ampere into resistance of the ammeter and current of the ammeter and resistance of the ammeter equal to current of the shunt and resistance of the shunt. Now if this is 10 milliampere is passed through it and 2 ampere is so if you it is 10 into resistance is 50. Now it will be 2000 or so since 2 ampere is 2 ampere is 2000 milliampere, so you can put it 2000 into the shunt resistance S. So if you calculate, S will be 500 divided by 2000 1 by 4, that is 0.25 ohm. So if you connect a shunt resistance of resistance 0.25 ohm, then the galvanometer will give a full scale deflection for a current of 2 ampere. Next question. The question says two parallel wires 1 meter apart carry currents of 2 ampere and 4 ampere respectively in opposite directions. The force per unit length acting between the two wires is. So this is a formula based question. We know the force per unit length. So suppose this is there are two wires, wire 1 and wire 2. So according to the principle, if they carry current in same direction, then they will attract each other. They will attract each other, that is, it will be like this. But when they carry current in opposite direction, they will repel each other. Here they will repel each other. Now the force per unit length acting between the two wires according to the formula, the force per unit length is given by mu0 by 4 pi to I1 I2 by d, where d is the distance between the two wires, and I1 I2 are the current passing through the two wires. So it will be mu0 by 4 pi. Mu0 is 4 pi into 10 to the minus 7, so it will be 10 to the power minus 7 into 2 into I1 is 2, I2 is 4, divided by distance is 1 meter. It will be 16 into 10 to the power minus 7 Newton per meter. And since, as I told you, since they are carrying the current in opposite direction, so the force between them will be repulsive. So they will repel each other. So the value will be 16 to 10 to the power minus 7 Newton per meter, and the force will be repulsive. So the correct option will be option B. Then question number 17. This is a different type of question. The question says, this question has statement 1 and statement 2. Of the 4 choice, there are different combinations. You need to find out what is the correct combination about these two statements. The statement 1 is, higher the range, greater is the resistance of the ammeter. Statement 2 is, to increase the range of the ammeter, additional shunt needs to be used across it. So the option is statement 1 is true, statement 2 is true, and statement 2 is the correct explanation of statement 1. Option B is, statement 2 is not the correct explanation of statement 1. Statement 1 is true, statement 2 is false. Option D is, statement 1 is false and statement 2 is true. So we have already discussed a few problems in today's session also. So I request you to please think about it, and we will discuss after a few minutes. Yes. Can anyone tell me what will be the correct option? Now we know higher the range, greater the resistance of ammeter. But this is not true because in order to have, so here you can see in the previous question, here we had discussed in order to increase the range of the galvanometer, we need to connect a resistance which is parallel to the existing galvanometer. But if you calculate the overall combination of the resistance when you connect it, then you will find higher is the range of the higher is the range, lesser will be the resistance of the ammeter, because since the ammeter resistance will be low, more current will pass through it. So we know V is equals to IR. So V by I is equals to R. So R is inverse proportional to I. So greater is the range, lower is the resistance. So the option, so statement 1 is not true, it is false. Now statement 2, to increase the range of the ammeter, additional shunt need to be used across it, which is true because we had already discussed today, two problems we have discussed. We have connected, we have calculated that when you use some shunt, if the shunt is of very low resistance, some current passes through the shunt and the range of the ammeter is increased. So the range of the ammeter can be increased by connecting the shunt. So the option 1 is, so statement 1 is false and the statement 2 is true. So the correct option will be option D. Now, next question. The question says sensitivity of a moving coil galvanometer can be increased by decreasing the number of turns of the coil, increasing in the number of turns of the coil, decreasing the area of a coil, or by using a weak magnet. Now, we know for moving coil galvanometer, the torque is given by BINA, and this torque, when this torque is stored in the spring and spring twisted by angle theta, this is given by C theta. So theta is BINA divided by C, where N is the number of turns, I is the current passing through that coil, B is the magnetic field, and A is the area of the coil. So this sensitivity means the value of theta will be more for a small amount of current. The value of theta will be more, so that it will be more sensitive. So we can identify very small deflection by using very small current because the value of theta is more. So since here the value of theta is directly proportional to the value of number of turn, that is N. So the sensitivity of the moving coil galvanometer can be increased when you increase the number of turns of the coil. Then let's go to the next question. The question says a time varying magnetic field is given by B, which is a function of time, is 5t square minus 4t plus 2, that exists in a region where a plane coil of area 0.2 meter square having 50 turns placed with its area perpendicular to the field. The induced EMF in the coil at t equal to 1 second is. Now we had already discussed the similar type of problem. This B is 5t square minus 4t plus 2. So we know the magnetic flux is given by B is equals to a phi is equal to BA and N is the number of turn BAN. So the EMF induced will be d phi by dt. So it will be d by dt of N A B. So N remains fixed. The magnetic field is varying with the time and the area is remaining fixed. So the NA is fixed, it will be dB by dt. Now if you calculate dB by dt, B is 5t square minus 4t plus 2. dp by dt is 10t minus 4 at t equal to 1 second. dB by dt is 10 minus 4, which is 6. So if you put here n is 50, number of turn is 50, area 0.2 meter square, area 0.2 meter square, dB by dt is how much? Is 6. So 50 into 0.2 is 10, 10 into 6, 60 volt. So 60 volt is the induced EMF in the coil at time t equal to 1 second. This is the time. Is this clear to all of you? Yes, same. Let's go to the next question. The question says the induced EMF in a coil is proportional to magnetic flux through the coil, area of the coil, rate of change of magnetic flux through the coil, or product of magnetic flux and area of the coil. We have discussed many times this same thing. So can anyone tell me what will be the correct option? Yes, anyone? We have solved numerous problems related to this induced EMF in the coil. So you should answer this question. The question says the induced EMF is proportional to magnetic flux through the coil, area of the coil, rate of change of magnetic flux, or product of the magnetic flux and area of the coil. Yes. So as we have already discussed, EMF is minus d phi by dt, that is the rate of change of magnetic flux through the coil. So the correct option is option C. Now the next question. A straight conductor carries a current of 10 ampere. An electron traveling with a speed of 5 into 10 to the power 5 meter per second parallel to the conductor at a distance of 1 centimeter from the conductor experiences a force. So there is a straight conductor and it carries current 10 ampere. An electron traveling with a speed of 5 into 10 to the power 5 meter per second parallel to the conductor at a distance of 1 centimeter. So this is the so suppose this electron is traveling. The distance is 1 centimeter from this axis of the coil, and the velocity of this electron is 5 into 10 to the power 5 meter per second. So what will be the force it will experience? Yes. Anyone? Can anyone tell me when a charged particle is moving in a magnetic field with some velocity, what will be the value of the force that it will experience? What is the expression for the force it experiences? Yes. And we have discussed many times, but can you tell me what is the name of the force that is acted upon a charged particle when it is moving in a magnetic field? What is the name of that force? Yes, anyone? It is called as Lorentz force, is not it? And this is given by F is equal to Q B cross B. This is the force due to the magnetic field when a charged particle move in a magnetic field. Now we know again, when there is a straight conductor, it has a magnetic field, and the magnetic field at a distance d is given by magnetic field due to a straight conductor is given by B is equal to mu 0 by 4 pi into 2I by d or mu 0 I by 2 pi d. This is the actual formula, mu 0 I by 2 pi d. But since we know mu 0 is 4 pi into the power minus 7, so we always write this term as mu 0 by 4 pi so that it will get cancelled out and only 10 to the power minus 7 remains. So this is the value of b. The angle between V and B you can calculate because it is given the electron is traveling with a speed parallel to the conductor. So the angle is known to you. Then the value of V is also known. The value of V is also given. The velocity of the electron, it is moving. So you need to just put all the values here and calculate the value of the force that it will experience. D is also given. D is 1 centimeter. So is there anyone who can calculate and tell me what will be the force? Yes, anyone? Can anyone calculate and tell me what will be the force that the electron will experience? Yes, can anyone tell me? So if you put all the values, the magnetic field will be mu 0 by 4 pi is 10 to the minus 7. 2 into 10 divided by d is 1 centimeter, 0.01 meter. So if you calculate, it will be 2 into 10 to the power minus 4 Weber per meter square. This is the value of the magnetic field. Now the magnetic field, when we know if the current is flowing in the direction according to, suppose this is, sorry, now if you know, if there is a, according to Fleming's right hand thumb rule, if the current is flowing in this direction, so the curling of the finger will give you the direction the magnetic field is produces. So the magnetic field will be in this phi direction. This is called as phi direction. So since it is moving, so this phi is perpendicular to this direction of the current. So since the velocity, that is the movement of the electron, is along the direction of the current, so the angle between the magnetic field and the velocity will be 90 degree. So here it will be BQV sine 90, which is 1. So if you put the value of B here, Q is the charge of the electron is 1.6 10 to the minus 19 coulomb. Then the velocity, if you put all these values, you will find the force that is acting on the electron is 10 to the 16 into 10 to the power minus 18 Newton. So here B is given, Q is 1.6 into 10 to the power minus 19, and V is also given 5 into 10 to the power 5. So the correct answer is option B, 16 into 10 to the power minus 18 Newton. A galvanometer having resistance of 3 ohm is converted into an ammeter by connecting a 3 ohm shunt resistance across it. In order to double the range of this ammeter, the additional shunt resistance should be connected across it. So this type of problem we have already solved a few problems in this class. So you can try this question later on. I will proceed to the next question because we have more. We have 2-3 questions more to cover, and I want to cover all the questions so that it will be beneficial for your upcoming exam. So now the next question, the question says a current of 10 ampere is flowing in a wire of length 1.5 meter. A force of 15 Newton acts on it when it is placed in a uniform magnetic field of 2 Tesla. The angle between the direction of the magnetic field and the direction of the current is. So this is a wire and a current is flowing inside the wire. The length of the wire is 1.5 meter and the current flowing in the wire is 10 ampere. The force, we know the force per unit length, we had already discussed the force per unit length of the wire. So when you consider the force which is acting on the wire, since it is placed in a magnetic field, it will be F is equal to ILB sin theta or IL plus B. So here we need to find out the angle between the direction of magnetic field and the direction of current. So the current and magnetic field, this angle theta we need to find out. We know I is 10 ampere. The length of the coil L is 1.5 meter and the force acting on it is 15 Newton. So if you put all these, it will be 15 is equals to 10 into 1.5 meter into B is 2 Tesla. So it is 10 into 2 is equals to 20 into 15 is 30. So it is sine theta. 15 is equal to 30 sine theta. So sine theta is 1 by 2, or theta is equals to how much? Sine 30 is 1 by 2, so theta is equal to 30 degree. So the correct option is option A, which is 30 degree. Now, next question. The question says two long parallel wires are separated by a distance r and they carry equal current. The magnetic field of one exerts a force F on other. The distance between them is related to r by 2 and the current in each reduced to I by 4. Now the force between them is. So we had already discussed the formula. Now this is the formula. That is the force per unit length between the two wires, where I1 and I2 are the current flowing in that two wires, and R is the, or D is the distance between the two wires. So here similarly there are two wires and that the distance between them is R and the current is I. So this force is mu 0 by 4 pi 2 I1 I2 by R, or since I1 I2 are same, mu 0 by 4 pi 2 I square by R. Now this I was changed to I by 4 and this R was changed to R by 2. So if you see here I by 4 square and here it is R by 2. So nu F will be mu 0 by 4 pi 2 into I by 4, sorry, I by 4 square divided by R by 2. So it will be mu 0 by 4 pi 2 I square by R into 2 divided by 16. 4 square is 16. This 2 will go to the top. So this is 2 by 16. That is 1 by 8. So F prime will be F by 8. So the new force acting on the two wire is reduced 1 by 8 times because the current in each is reduced to I by 4 or 1 by 4 times, and the resistor is, and the distance is changed from R to R by 2. Since the force is direct proportional to the current and inversely proportional to the force is inversely proportional to the distance between the two wires. So as a result of the change in current and the distance between the two wires, the force acting between them will change. So it will change by 1 by 8 times that of the initial situation. So now this is the last question of the session. The question says two indefinitely long parallel wires carry equal current flowing in same direction. The magnetic field exactly halfway between the two wires is. So in the question it says there are two infinitely long parallel wires. They carry equal current. So this is also I, this is also I, and they also in same direction. So now we know, we have already discussed that if they carry current in same direction, the force will be attractive in nature. So it will, so the force on, suppose this is A and this is B. So the force on B due to A will be in this direction because this will attract this. Similarly, the force on A due to B will be in this direction. So there, so the force will be acting in opposite direction. That is, they will be attractive. So when the force acts on the opposite direction, and we know since the current is same, the force we know here the force of a current carrying conductor F is equal to IBL sin theta. Now you can clearly see. Now here in place of this B, we will put the magnetic field produced due to the second coil. So now current I flows to this coil. It produces some magnetic field around it. Now when the second coil is present in the field of this first coil, then it will experience some force. Since the current in both the wire is same, so the magnetic field they will produce is same. So the force they will exert on each other is same. So when you calculate the force at exactly halfway between the wires, so suppose this is the distance D. If you measure here, that is the distance is D by 2 and the remaining distance here is D by 2. So the force will be exactly equal to each other because this point D is at same distance from the point from the wire A and wire B. So the force will be equal and opposite to each other. So they will cancel out. So the net force will be 0. So the so the net magnetic field is also 0 because the magnetic field they produce, they will be equal and opposite. So since the force is 0, also the magnetic field is becomes 0 because the current are not 0 here. It has some value. So the field between the two wire will be 0. So suppose this is the current direction. Now according to the Fleming's right hand rule, the magnetic field produced will be in anti-clockwise direction. Now if in this case this is the direction of the current, the magnetic field is produced will be again in anti-clockwise direction. So they will cancel out each other and the net force will be 0 at exactly halfway in between them. So these are the questions we discussed. Is there any doubt in any question that we discussed today? Yes, anyone? So these were the questions that I had covered. Now the all the interaction sessions are completed. I won't be taking the interaction session in the next Saturday. So all the best for your exams. I hope you do well in the exam. Thank you all for joining in the today's interaction session and also for registering the course which is being provided by NPTEL. Myself Vivekananda Naik. I am from IIT Delhi. That's it from my side.